Hi everybody, today I'm gonna introduce you a new topic of Module 1 Mathematics from our EASA Part 66 exam preparation courses. In the description below, you found the link of previous video to make a review of last course. You found also a link to practice exercise and understand this course. Mathematics module contains 3 chapters: Arithmetic, Algebra, and Geometry. We still continue on the first Arithmetic chapter. Arithmetic course, we still continue our first Arithmetic course. Arithmetic topic contain also many courses. You can see that in previous video where we've explained with large detail the syllabus of this module. So every candidate who won't pass this exam must understand of this subject matter and familiarized with this exercise. In this video we will see primer factors, primer numbers, and low common multiple and high common factor. Last one. Every topic will be good explained by one of our team. So this topic will be followed by my colleague Kanzboy. So let's start.
Hello everyone, today we are jumping back on the arithmetic train. Today we're going to talk about a couple of things here shown on my screen, such as the lowest common multiple, highest common factor, prime factors, and prime numbers. So let's get started. So first off, we're going to talk about, we're going to review actually what a multiple and what a factor is. So a multiple is a number that can be multiplied by all other whole numbers. So for example, if I want to find all the multiples of 2, I'm going to take 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5, all the way down to infinity. And these products here would all be multiples of 2, right, all the way down to infinity. On the other side we have factors, and factors are numbers that we can multiply together to get another number. So for example, 2 times 3 equals 6. That means that 2 and 3 are both factors of 6. And if we remember, if we were to find all the factors of 6, it'd be everything that 6 can be divided by. So 6 can always be divided by 1. And then 2, 3, as we've shown above, and itself. So some key things to remember here is that every number will have 1 and itself in a factorization. Okay, so moving on. Now we want to talk about the lowest common multiple. We also refer to this as just LCM. Okay? So, the lowest common multiple of 2 or more numbers is the smallest positive number, which is a common multiple of the numbers. So I know that sounds a little confusing, but if we do an example here, we'll see that it's actually very straightforward. So an example is if we want to find the multiples. The lowest common multiple of 4 and 6. So the first thing we're going to do is write down the multiples of 4. Multiples of 4 are 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. and that goes on forever, like we talked about above. Now we are also going to write down the multiples of 6. So we start with 6. 6 times 2 is 12, 6 times 3 is 18, and 6 times 4 is 24. Now we're going to find the lowest common multiple. So we can see here that 6 doesn't appear in 4. 12, does it appear in 4? Oh, it does right here. 18 doesn't, 24 doesn't, but we have already noticed that 12 is both in 4 and 6. So 12 is the lowest common multiple of 4 and 6. Pretty straightforward. Another example would be to find the lowest common multiple of 7 and 8. So again, we're going to start off by listing the multiples of 7 and the multiples of 8. So the multiples of 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 28. 7 times 5 is 35. 7 times 6 is 42. 49. 56, and infinity. And then we'll also do the same for 8. 8, 16, 24, 32, 40, 48, 56. And again, if we circle through, we don't see an 8 in 7, we don't see a 16 in all of our 7, we don't see a 24, 32, 40, 48, but we do find 56. So that would mean that the lowest common multiple of 7 and 8 is 56. So that's pretty straightforward there, right? So your 3 steps, if we go over that. 1, list the multiples of each number. And then 2, locate the smallest common multiple. Now if we move on to the highest common factor, we also refer to that as the HCF. And this is when we have the highest common factor of 2 or more numbers is the highest number that will divide into the 2 numbers. So the easiest way, just kind of like above we started, was by listing all the multiples above. Now we're going to list all the factors and we're going to find the highest one. So for an example, we have find the highest common factor of 12 and 48. So first, we're going to take 12 and we're going to list all of its factors. So the first thing we remember about factors is each number has itself, 1, and itself. We can put that at the end because we know that's going to be the last one. Now we also know that 12 divided by 2 is 6, and 12 divided by 3 is 4. So those are all of our factors of 12. Now 48 might be a little bit trickier, but we can do the same thing here, right? 1, 48 at the end. 2 divided by 48, or 48 divided by 2, is 24. 48 divided by 3 is 16. 48 divided by 4 is 12. And 48 divided by 6 is 8. Also, so now that we have all of our factors listed, we can go through and we can figure out what our highest common factor is. So we're going to start from the right then, because all of our highest numbers are on the right. 48, no. 24, no. 16, no. Oh, but 48 has 12, just like 12 does. So that is going to be our highest common factor. Pretty straightforward. So we can do another example. We can find the highest common factor of 24 and 36. So first let's find all of the factors of 24. Those factors are 1, 2, 3, 4, 6, 8, 12, and 24. Find all the factors for 36. If you want to try and practice on your own, you can pause it in between me doing these. So the factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18, and 36. Now we can notice here that there's a bunch of similar factors. So 1, 2, 3, 4, they will have 6. They have 12. But we just want the highest common factor. So again, the highest common factor is equal to 12. Now, using lists as shown above to find both the lowest common multiple and the highest common factor can be super time consuming for big numbers, but also for some small numbers, especially for factors if we don't have a calculator and we don't want to be trying to figure out every single number. So there's got to be an easier way. And to use this easier way, we need to learn about prime numbers and prime factors. So first, we're going to talk about prime numbers. Now, a prime number is a number which only has two factors, and those factors are 1 and itself. So, if we remember talking about factors above, a number like, we'll say 9, always has 1 and itself. But in this case, 3 times 3 is also 9, so it also has 3 as a factor. So 9 is not a prime number because it has 3 factors. Now, another example is if we look at 7. So 7 we know can be divided by 1 and itself, but can 7 be divided by anything else to get a whole number? The answer is no. That means 7 only has 2 factors, 1 and 7, 1 in itself, which means 7 is a prime number. Another example of a prime number is 19. So 19 is divided by 1 and itself. Now 19 isn't divided by 2, 3, 4, 5. So since we only have 2 factors again, 19 is a prime number. Now we're going to need to know our prime numbers for later on. So here is a list of the first 8 prime numbers. And the first 8 are 2, 3, 5, 7, 11, 13, 17, and 19. And above, here's where we showed 19. We also showed 7. So the same thing goes for all of them. So if we show 2, 2 is only divided by 1 in itself. Same with 3, 1 in itself. Same with 5, 1 in itself. And so on for all of the prime numbers. So now let's move on to prime factors. Now prime factors are every whole number. Every whole number can be written as a product of prime factors. So to write a number as a product of prime factors, we continuously divide a number by a prime. So our first example here is write 924 as a product of primes. right? So product being a multiplication of primes. So if we start with 924, we want to divide it by the smallest factor, but not 1, right? Because 924 divided by 1 is just going to be 924, and we're not going to get anywhere with that. So what we want to do is divide, this is an even number, so we're going to divide it by 2, which gets us to 462. Now we're going to take 462, and again, this is an even number, so I'm going to divide it by 2, and I get 231. So we know that, taking a sidebar, 3 times 7 is equal to 21, and since 231 ends in a 1, we can try dividing it by 3. So we have 231 divided by 3 is equal to 77, and then we can take 77 and divide it by 7, which gives us 11. And this is a prime number, right? If we go back up here, we can notice 11's a prime number. So that means we can stop here as we ended on a prime number. And writing 924 as a product of primes will then look like all of these numbers here that we used to divide with. So the answer is going to look 2 times 2 times 3 times 7. Now we ended on a prime like we want to, so we're going to multiply by 11 as well, and that equals 924. Okay, so the big things to remember in writing numbers as a product of primes is we always want to end with a prime number. That's how we know that there's no smaller number we can find. So here's another example. Write 240 as a product of primes. Now we're going to use the same steps. So right, we have 240. Again, it's an even number, so I'm going to divide it by 2. That gives me 120. Then, first, get this color-coded properly so we can see it. 120. And then we're going to take 120. And again, it's an even number, so I'm going to divide it by 2, which gives me 60. And then I have another even number, so I'm just going to divide it by 2, which gives me 30, which again is an even number, so I can divide it by 2, which gets me to 15. And then 15 can be divided by 3, which gives us an end goal, a prime number of 5. So we know we're done, we've hit a prime number. So then I can write this as all of these multiplied together and this one. So there's a lot of 2s, so we got to make sure we include them all, right? So 1, 2, 3, 4 2s times 1 3 times 5 is equal to 240. Pretty straightforward. Okay, so let's try one more example. So we're going to write 231 as a product of primes. Now this one ends in an odd number, so we're going to try something new again, right? So remember from above, it ended in a 1, and we know that 3 times 7 is equal to 21. So we're going to take the smaller of the 2, 3. So I'm going to go 231 divided by 3 gives me 77. And I know, just like above, here's a 7, so I can divide by 7. So I can go 77 divided by 7 equals 11. And again, 11 is our prime number. So if I write 231 as a product of primes, it will be 3 times 7 times 11. Pretty straightforward. So there's another way to write numbers in terms of prime factors and that's by using a factor tree. So if we use that, it's a quick example here, just a small example. So we know that 2 is a prime number, so the factor tree of 2 is 1, 2. Pretty straightforward. Just lines like that. And once we have a bigger number, it may look something like this. Number, 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 number. And the important thing here is we want prime numbers over on this side. And when we're done, when we have a prime number also on this side. Okay? So, an example, a bigger example for prime factorization of a tree, shown as a tree, is write 630 as a product of primes. So, we start off at the top with 630. Now, it's even, so I'm going to divide it by 2 on this side. 630 divided by 2 is 315. Now I've got a 5, so I know I can divide it by 3. 315 divided by 3 is 105. Another 5, 3, 35, another 5. This time I'm going to end up dividing by 5, and I get 7. Okay, so now I know I'm done because I have both a prime here and a prime here. So if I'm going to write 230 or 630 in terms of a product of primes, it'll be all of these circled green numbers. So 2 times 3 times 3 times 5 times 7 is equal to 630. So again, more of a visual way to do that. Now that we know about prime numbers and prime factors, we can move on to an easier way to find the lowest common multiple and the highest common factor. So, if we start with the lowest common multiple, and the way that we're going to do this is by using prime factors method. So we're going to use what we just talked about above to help us find the lowest common multiple. So, to begin with, to find the lowest common multiple of 2 or more whole numbers, we have 2 steps. Again, so we're going to write the numbers in terms of prime factors, and then we're going to multiply each greatest number, the number of times it occurs in either number. So that might sound a little confusing again, but bear with me. It's something that we can easily master. So if we start with an example, we're going to find the lowest common multiple of 12 and 80, right? So some pretty big numbers that we wouldn't want to write out a bunch of multiples for. So again, we're starting off by step 1, write numbers in terms of prime factors. So first I have 12, and the prime factors of 12, if I were to do a tree, 2 times 6, 2 times 3. So here's my tree. Now I'm going to use 2, 2, and 3. So 12 is equal to 2 times 2 times 3. Now we also have to do 80. And 80 to 40 to 20 to and 10 and 2, 5. Okay. So then 80, 2 times 2 times 2 times 2 times 5. We'll just double check this quick, and we can show how we can do that. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16, and 16 times 5. Now that's not something that I know quite in my head, so I can stack and multiply. 5 times 6 is 30. Carry the 3. 5 times 1 is 5, plus 3 is 80. So we know that this is right. So I have my 2. Now, my second step is to multiply each number by the number of times it occurs. Okay, so if we look at this, 12 has 1 3, and there is no 3 in 80 in all of these numbers, so I know a 3 is going to go into it. Okay, now 12 has 2 2s, but 80 has 4 2s, so I'm going to take the higher number. I'm going to take these 4 2s, 1 2 3 4. Okay, so now these 2s are gone as well, and we have a 5 left over. Now there's no 5s in 12, so we're going to take the 5 as well. And that is equal to, you can grab a calculator for that if you would like. So 3 times 2 times 2 times 2 times 2 times 5 is 240. And 240 is the lowest common multiple. Okay, so a little bit more straightforward than the steps right out for us. So we can do another example. And we can find the lowest common multiple then of 3 numbers. So 9, 15, and 40. So again, we're going to want to list the prime factors, factorization. So 3 and 3. And that's it. 15, 3 and 5, and that's it. And 40, 2, 20, 2, 10, 2, 5, that's it. So if we write them out, 9 is 3 times 3, 15 is 3 times 5, and 40 is 2 times 2 times 2 times 5. So now if we want to write that, or we want to find the lowest common multiple, 9 has 2 3s, 1, 2. No one else has more than 2 3s, so we get to cross this guy out, and our 3 by 3 comes down here. And now we look at 15. 15 has a 5. 40 also has a 5, but only 1, so we can cross it out because we only need 1 5. We can grab the 5 from 15 or from 40. And then what we're left with is 3 2s, and since there's no other 2s, we're going to take all 3 2s, and that gives us an answer of 360, which is our lowest common multiple of 9, 15, and 40. Okay? So then, now that we know how to do lowest common multiple, we're using the prime factor method, we can also find the highest common factor using the prime factor method. Okay, so our steps here, again, write the numbers in terms of prime factors. 2, the product of all common prime factors is the highest common factor of the given numbers. So the product of all common factors equals the highest common factor. Okay, so again, might sound a little bit tricky, but we'll do a couple of examples. So our first example, we want to find the HCF of 240 and 924. Some big numbers. So if we were to do the prime factor trees, or just prime factors in general, 240 ends up being 2 times 2 times 2 times 2 times 3 times 5. I think we found that out up here. Yep. 2 times 2 times 2 times 2 times 3 times 5. Okay, and we know that 924 is, you can pause it here and do it yourself if you'd like to, but it is 2 times 2 times 3 times 7 times 11. Now, our second step says the product of all common factors is the highest common factor. So if we multiply all of the common factors together, that is the highest common factor. So if we go here, okay, so I'll get out a different color. Now, here's a common factor, 2. Alright, so 2 is going to go down here. Now there's another 2, so we can pair those up as well. So we get another 2 down here. And there's 2 more 2's, but there's no more 2's down here, so we can cross those out. There's a 3, so we can pair those up, go times 3, and then nothing else. Right, so 7, no, 5, no, 11, no. So 2 times 2 times 3 is 12, and that's multiplying all the common factors together. So 12 is our highest common factor of 240 and 924. Okay, pretty straightforward. So if we try to do one more, let's use some numbers from up here maybe. Let's use 40 and 15 because we know those two, right, from above. Okay, so we want the HCF of 40 and 15. So if we do, just for fun again, let's work on those factor trees. 40 is 2 and 20, 2 and 10, 2 and 5. And 15 is 3 and 5. So we know all of these extra ones are the ones we're looking at. And we know that we want the common ones. 2, there's no 2 over here, so all 3 of these 2's are lost. 5, there's a 5 over here. So then the highest common factor is 5. Right? So that's by using a factor tree. So that is the faster way to find the lowest common multiple and the highest common factor. Now before we wrap up for this lesson, let's do a couple of more examples so that you have time to practice with some solutions. Alright, so I'll write them up. I will briefly pause so you have time to do the question on your own, and then I will give you the solution. Alright, so first, we want to find the lowest common multiple of 2, 3, and 6. Alright, so you can pause here. We can remember that there's 2 different ways to find the lowest common multiple. One might be better than the other in this case. Just depends on what you prefer to do. Okay, so I'm actually going to list all of the multiples because they're numbers that I know. So 2, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and so on. 3, 6, 9, 12, 15, 18, 21, 24, and so on. 6, 12, 18, 24, and so on. Okay, so I've done the first step. I've listed all of my multiples. Now, we want to find the lowest common multiple, right? Lowest common multiple, so we can start from the left, the lowest side. 2, only in that one. 4, or 3, no. 4, no. Oop, 6, I see 6 across the board. So my lowest common multiple is 6. All right, next example. Find the highest common factor of 21 and 35. Whoa. Crazy 3 and 35. All right, so again, you can pause the video here, try it yourself. Then remember, again, there are 2 ways. You can choose which one you prefer. All right, so I'm actually going to do, again, the same thing. I'm going to list all the factors just so I can see them and I know these numbers. So 21, 1, 2, 7. Oh, that's not right. 7 times 2 is 14. 3 and 7. 7, 14, 21. Yep, there we go. And 35. 1, 5, 7, 35. Okay, so by looking like this, we know that these are common and these are common. But we want the highest common factor. So like this. So our HCF is equal to 7. All right, hopefully you got that one. Now we're going to do a product of primes. So we're going to write 1638 as a product of primes. Now don't panic. I know it's a big number, but you can do it. All right, so pause the video here if you need to. All right. Remember, we can do it in 2 ways. We can do it as a prime factor tree, or we can just go through and divide. Depends what your preference is. Okay, so I'm just going to divide because I don't want to build a giant factor tree. So I start with 1638. It's an even number, so I'm going to divide it by 2, and that gives me 819. Now we haven't come over across a 9 yet, but I know that 9 divided by 3 is 3. So I'm pretty sure I can divide this by 3. So I can go 819 divided by 3 is equal to, and if we do that calculation, we get 273. Awesome. So again, a 3. And I know that 3 divided by 3 is 1, so I should be able to divide this by 3. 273 divided by 3 equals 91. A 1 again, and we know a 1, 7 times 3 is 21, so that should work out, and we want the smallest one. Oh, nope, this time we're going to actually use the 7. So I go 91 divided by 7 gives me 13. So I chose 7 in this case because I get right to that prime number. Alright? So then, what we do, we ended with a prime, so all of these get multiplied together, and this guy. Okay, so that gives us an answer of 1638 is equal to 2 times 3 times 3 times 7 times 13. Alright, another question. What are the prime numbers from 20 to 30? Maybe a better word is between 20 and 30. Okay, so pause the video here. Remember that a prime number only has 2 factors, one in itself. Okay, so the prime numbers between 20 and 30 are 23 and 29. Okay, so only those 2. Alright, hopefully you got that one as well. Now we're going to find the lowest common multiple of 22, 36, and 90. Okay, so 3 numbers this time. So maybe think about the more efficient way to find the lowest common multiple of those 3. Okay, so I am going to write out their factors. So actually I'm going to do a factor tree. 22, 2 times 11, perfect because those are both prime numbers. 36, 2, 3, 3. Oh, I messed up. 2, 2, 3, 3. Okay. Alright, you should know what numbers are in here, so I shouldn't have to write those in. And, oh, don't forget, we have a 5 here. No, we don't. 2, 2, 3, 3. Ah, I wrote this wrong. There we go. There should be a 3 here. Perfect. Okay, so you should be able to fill in these white spots. And then if we do 90, again, you can do the factor tree. 2, 45, 3, and 3 times 5, 15. Okay, so now that we have all of our numbers, we have to go through and choose the most common ones. Okay, so we have 1, 2 here, but we have 2 2s here and 1, 2 there. So we're going to grab our 2 2s and cross out the others. So we have 2 times 2. Now we have 11. 11 isn't anywhere else, so we're going to put that in there. Awesome. Over here we have 2 3s. We also have 2 3s and 90, so we can grab either one. And we have a lonely 5, so we grab him as well. Okay, and when we multiply all of those together, we get 1,980. Crazy big number. Okay, so that's why I like to use the prime factorization method. Again, we can use trees or we can just list them depending on which you prefer. And one last question here. We're going to find the highest common factor of 22, 36, and 90. Okay, so 3 numbers. So we'll let you think about which way you're going to use that. Pause the video and give it a try. Okay, so again, I'm going to do some trees just because they're fun. 22, I know, right? And they're the same as above. Actually, we don't have to do them. They're the same as above then, right? So we'll just write them. 22, 2 times 11, 36, 2 times 2 times 3 times 3. Is there another? Nope, that's it. And 90. We have this one over here too. 2 times 3 times 3 times 5. Okay. So now, if I go through and I need to find the factor that is common in all of them. Okay, so I know 2 is in all 3. And that's it. Okay, so that's the only one that has all 3. Yes, we do have 2 3s and 2 3s, but there's no 3s up here. If we had a 3 up here, we could add in those 2, but we don't. So we leave those guys out. There's no other 11 anywhere else, no other 5 anywhere else, so we also leave those ones out, which means that the highest common factor, 22, 36, and 90, is 2. Okay, so that is the end of today's lesson. I hope you guys understand a little bit further on lowest common multiples, highest common factors, prime numbers, prime factors, and hopefully you got all these practice questions correct. If you didn't, Google some more, get some more practice in. Watch the video again. That might end up helping you as well. Alright, so I hope that this helped, and I hope that you have a great rest of your day. Okay, thanks. Bye.